This is the time-sensitive mechanics project. In it, we were supposed to use a motor and the RTC to create a device with time-sensitive controls. I made a mini water pump which can be set with a timer. In order to function properly, the motor must pull water in from the input and push it out the output. To do this, the motor spins a set of fins called the impeller. When spinning, the impeller creates a centrifugal force. A centrifugal force is a spinning motion that pushes objects away from the center. This means the water will be pushed to the edges of the casing. Since the output tube is along the edge of the casing, the water is pushed through it. As the water is pushed to the outside, it creates a high concentration along the edges and a partial vacuum in the middle. This vacuum will suck up water from the input pipe tube. Before operating, the pump needs to be primed. When the pump is filled with air, it is unable to pull the water through. This is because the vacuum created by the air is not strong enough for the water. Due to the design, when the pump is off, the water doesn't stay in the pump and will flow out. This means that it has to be primed every single time it is turned off or on. To demonstrate the timer, the pump will move air instead of water. To control the timer, there are 3 buttons. One button increases the time, one button decreases the time, and the other starts the timer. I based the timer off of a microwave timer in that as the count increases, the increments increase as well. At 10 seconds, the increment is 5 seconds. At 30 seconds, the increment is 15 seconds, and so on. When the timer is activated with the start button, the other buttons are disabled as to not interfere with the timer. And then a logic high is sent to the Darlington pair, which will turn on the motor. Then the LCD screen will display the countdown. The countdown will continue to lower until it reaches 0, when it will display a done notification.